Welcome, Leandro and Diego.
Thank you. So we are Leandro Mainers and Diego Sor. We both work at Core Security Technologies Consulting Services. Mainly we do pen testing and source code auditing there. So basically based on that, we did our research and we are researching all the time based on what we see out there. So enjoy the talk and let's start. So first of all, an agenda for this talk. We are going to review or to reintroduce some of the concepts of web. Then we are going to introduce WPA migration mode, which is the main topic of this talk. Then we are going to talk about the attacks, how to attack the WPA migration mode, and some mitigations and recommendations in order to avoid or to prevent these attacks to happen. So basically, this is the agenda for the talk. So web, we all know, or probably, yeah, we all know that is broken. At this point, we know that it shouldn't be used. But well, anyway, we are going to review some of the key concepts that are the building blocks of our attack. So web was meant to provide confidentiality, to provide access control and integrity over the packets we transmit. So web is based on RC4, which is a symmetric cipher, meaning that both endpoints know the key and the key is the same on both endpoints. And it is a stream cipher, which means that the encryption happens one digit at a time, so each digit is encrypted independently of the rest of the stream or the packet. Then it includes something they call the ICB, which is the CRC32 of the plain text message. This is the integrity check value, which is transmitted in order to ensure the integrity of the packet. And then for the key management, 802.11 does not provide any key management service. So web depends on the end user to distribute and to provide a secure way to distribute the keys. So generally the keys are statically set and configured somewhere in a file, in a configuration, web page, whatever, depending on the equipment. So this is the basic diagram of the web encapsulation. We have the plain text that goes through the CRC32 calculation. We concatenate the two, meaning the plain text and the CRC32. Then we have the initialization vector and the web key. We concatenate the two, and this is called the seed that enters the RC4 pseudo-random number generator, which is basically the RC4 generator of the key stream. So the key stream is the encryption material that we are going to XOR with the concatenation of the plain text and the ICB. So from there, we got the ciphertext. So basically, we have the key stream, we have the plain text message concatenated with the ICB, and we exclusive OR those things to obtain the ciphertext. Then we prepend the initialization vector. This is in order to the receiver to know the initialization vector that is used to decrypt the packet. So this is the basic diagram of the web encapsulation. So back in 2001, one of the first papers published about how to tamper a web message. What does it mean? So we can build a new message based on the old ciphertext that is still valid. So basically, one of the key elements for this to happen is that CRC32 is linear with respect of the XOR operation. This is the basic that we need for this to happen. So we claim that it is possible to build a new message, a new ciphertext, C2, based on the first ciphertext and a delta value that is arbitrarily selected by the attacker, and we can control it. So basically, knowing the ciphertext and setting a delta value, we can build a new ciphertext which is valid for web encapsulation. So in layman's terms, we have to sort the data with the mask delta. This is the arbitrary value the attacker uses and selects, and sort the ICV, meaning the CRC32 of the original message, with the ICV of the mask, meaning the ICV of delta, right? So having this in mind, we are going to show an attack based on these properties. So now a brief introduction to WPA. What is WPA? Basically, Cisco has in its 1200 AP series this kind of functionality that allows clients using web and WPA to connect to the same service set identifier, the SSID. So WPA clients capable of TKIP and authenticated key management can connect to this SSID. 802.1x clients, such as legacy LIP clients and clients using TLS, but capable of authenticated key management, but not TKIP. This is called the dynamic web clients. And finally, web clients not capable of TKIP or authenticated key management. This is the old web client stuff, which is where the key is set manually. So using the same SSID, we can connect with either a WPA station or a web station. So this is how we can identify an AP working on this particular configuration. So we have the multicast cipher and we have the unicast cipher. We see that for the multicast cipher suite, the beacon shows that it is using the web 104 bits, and for the unicast cipher suite, it is using TKIP. So both ciphers are used on the same AP, and they are advertised in the beacon. So basically, we have both ciphers that we can use. So for multicast and broadcast, which is basically that we are going to show, we can use either web or WPA. So using web as a multicast cipher allows web and WPA stations to decrypt multicast traffic. So basically, this AP will use web for multicast and for broadcast, and for the stations that are only web stations, and will use WPA for unicast traffic that is for WPA or TKIP in this case stations, right? So the AP tracks which station is web and which station is WPA and forwards. Remember that 802 wireless or Wi-Fi in general is a switched network. So basically the AP forwards each packet to each station, taking in account the type of encryption the station is using. So if the station is using web, the unicast packet will go in web. If the station is using WPA, the unicast packet will go using TKIP. But for the multicast and broadcast packets, the IP will always use web. So this is the basic configuration for an AP working in this particular way. So WPA becomes optional from the Cisco's documentation. A cipher suite containing TKIP and 40-bit or 128-bit web configuration, and a static web key in key slot 2 or 3. This is one of the differences we find with the typical web configuration, because this is a requirement to put the key in slot 2 or 3. Then we have the capture of the terminal, where we configure the AP. So you see that the encryption mode ciphers are TKIP and web 128 bits. The encryption key is in slot 2, and the key is here, the SSID, and then you see the authentication key management as WPA optional, because this is a requirement for the AP to work. So how to detect this AP working? So basically, working in WPA migration mode. Basically, we are going to look for the beacon frames. So first of all, try to filter the beacon frames using the frame control type subtype field. Then that the beacon must, the WPA element must be present within the beacon. Then the multicast cipher suite, which is inside one tag of the WPA elements, must be multicast cipher suite web 40 bits or multicast cipher suite web 104 bits. And finally, the unicast cipher suite is TKIP. So unicast cipher suite, TKIP. So this is the basic element we have to look for when we are looking for an AP working in migration mode. So this is all the filter elements combined in one visualization filter and a Wireshark capture of the beacon frames. Then we have Kismet here, the tool for wireless information gathering, pen testing, whatever you want, that we patch in order to detect these APs working in migration mode as web APs in red, if you see on top of the image. Why? Because as the talk goes by, we are going to show that having an AP working in migration mode will pose the same risk as an AP working in web. So it is important to flag it as a web AP. In fact, this is not a web AP, but we are going to show that the risk is the same. So we see there the details of TKIP, cipher, web cipher, and we configure the AP in pre-share key because it was easier for us to test this, but you can use 802.1x or whatever. And then the details of the AP, the BSSID, the ciphers, and all this information that is shown in the capture. So now Leandro is going to talk about how to attack